Okay, so in this video, we are going to be looking at the natural log and log functions and how you integrate the natural log function and use that to solve different integration problems. Looking at log functions, we're familiar. Remember, the natural log is just log base e, and that is what the natural log is. Now, let's take a look at the log rule for integration. If you remember, when you found the derivative of the natural log of x, try that again, that was 1 over x. And the natural log and log functions are all composites, meaning you have this thing inside the natural log function, right? So it was always when you did the natural log of 2x, for example, that was 1 over 2x times the derivative of 2x, which was 2. All right, so you have to remember that that's why there's u substitution. You have to think of it as a composite function. But the integral then of 1 over x is just the natural log of the absolute value of x plus c. This is indefinite integration. You have that plus c, and it's the absolute value because you cannot have a negative natural log. All right, so let's try an example. Go ahead and try this one, the integral of 2 over x dx. Try this one on your own and then come back and see how you did. Okay, so you should get 2 natural log of the absolute value of x plus c. Now understand with logs and natural logs that a product, so if you have 2 times the natural log, you can rewrite that as the natural log of whatever this is. In this case, it's x squared, right? So we really want to rewrite it like this versus like this up here. I think either one will be okay, but just remember the basic rules of natural logs allow you to take products and use them as exponents. Okay, let's try another one. Here you're going to have to use u substitution. So apply u substitution to solve this one. Try it on your own and then come back and see how you did. When we figure out what the u has to be, it has to be the 4x minus 1. Then du over dx is equal to 4. And remember, I'm trying to figure out what to substitute in there for dx. And I know dx is du over 4. So then I make that substitution or write in there for dx. And when you do that, you have the du, which is right here, and then the over 4. I took the 1/4 out front. So you would have then the integral of just 1/4 times the integral of 1 over u du, which is 1/4 natural log of u, and we plug the 4x minus 1 back in for u. We don't have any limits, so we add that plus c. Now, again, you could take this and rewrite it, so it could be the natural log of 4x minus 1 to the 1/4 plus c. I think either one of these will be just fine. To the 1/4 doesn't make as much sense, but either one of those would be just fine. Okay, so here we're finding the area under the curve, which we know now is the integral, and we're using the log rule. We have the function is x over x squared plus 1, and we are going to find the area under that curve. So we'll set up a definite integral where it goes from x equals 0 to x equals 3. So from 0 to 3, and then our function is x over x squared plus 1. And we can't really integrate that as it is, so we have to use u substitution. So figure out what your u would be, set it up, integrate, and then come back to the video. And you have your limits, so it's upper limit minus lower limit. And you can either plug your limits into the u function or plug the u function back in to evaluate that way. All right, so try this one on your own and then come back and see how you did. Okay, so let's see how you did when you set up your integral. We did that. Our u should be x squared plus 1. And then when we solve for dx, that's du over 2x. And so I am taking that and I am substituting it in for my dx right there. And that's where I get the du over 2x there. And you notice a couple things happen. Number one, the x's will cancel, right? Then you just have du over 2, which is the same as du times 1/2. So then I took that 1/2 and put it out front. Then I had to worry about my limits. So then looking at my limits of integration, it was 0 and 3. I plug those back into my u equals, which is right there. And so you get u equals 3 squared plus 1. So my new upper limit is 10. And my lower limit is 0 squared plus 1, which is just 1. So now everything's in terms of u, and I don't have to worry about plugging u back in. So I integrate 1 over u, and that's the natural log of u. And it's still times the 1/2. Then you plug in your upper minus your lower. And the natural log of 1, this is just 0 anyway. And so it just becomes 1/2 natural log of 10. Whatever that would end up being, or the natural log of the square root of 10, whatever, however you want to write that. But this is kind of where we're stopped. Let's not let's not plug that into a calculator. We'll stop right there. Okay. So here's a couple different examples. They're all a little bit different in recognizing quotient forms of the log rule. Just more practice. Go ahead and try these on your own. And on these, you will have to use substitution. So try these 3, A, B, and C on your own, and then come back and see how you did. Now, they all fit into a general rule, right? So if you notice the pattern, it makes it a lot easier. For example, on this first one, your u has to be the x to the third plus x. And you notice that the derivative of x to the third plus x is equal to your numerator. So when you end up setting it up in u substitution, you end up dividing by your derivative, which will then cancel out with the entire numerator. So the shortcut is, you know they're going to be canceling out, and it's going to be 1 over u times du after all the substitution. So if you notice that, then you can quickly figure out that the integral is going to be the natural log of your x to the third plus x, the absolute value of that, plus c, because everything else will cancel out. So look for those patterns on the other two, and then come back to the video. On B, you should have noticed that your tangent of x, that's going to be your u, and the derivative of tangent is secant squared, which is going to cancel out with the secant squared there. So your integral is just natural log of tangent x plus c. And then on part C, this one is a little bit different because when your u is 3x plus 2, it doesn't cancel out with the 1. Obviously, because you'll be left with, when you do this and solve for the dx portion, you would have du over 3 is equal to dx. So that's where this 1/3 comes from. And it's a constant, so it can just be pulled out front. So then you would have 1/3 the natural log of 3x plus 2 quantity plus your c. Okay? So remember that kind of as you're going through and solving some of these. On some of them, if you notice on this example, the bottom, the numerator and the denominator, they both have leading terms of the same degree. So if we found derivatives of one, it will not cancel out with the other one. So in this case, we're going to have to divide the bottom into the top to kind of break it up a little bit before we integrate. So use your Algebra 2 long division skills and divide the bottom into the top, try it, and then see how you did. If you need a little push for the long division piece, if you divide the bottom and the top, so you can look at the leading terms. How many times will x squared go into x squared? Well, it goes 1 time, remember, and then you take that 1 and multiply to the x squared and the 1 to get what these terms are down here. And remember, so you're subtracting all of those away. So x squared minus x squared, 1 minus 1, and then you'll just be left with that positive x. So this right here, that is your remainder. And remember, your remainder goes in the numerator of what's left. So now we have, from that integral, we have then just the integral of 1 plus x over x squared plus 1 dx. Now you can remember, you can separate this into two separate integrals. So it could be the integral of 1 dx, which we can do pretty easily, and the integral of x over x squared plus 1 dx, where we would use substitution. So if you haven't tried this, pause the video and finish it out. The integral of just 1, that is just x. But then over here, you would have to use substitution, where your u is the x squared plus 1. And remember, the du over the derivative of this, which is 2, that's what is your 2x, and that's where this 1/2 comes from, because you're going to pull that 1/2 out. So then it just becomes 1/2 the integral of 1 over u, which is the natural log of u, and then plugging u back in there, we get 1/2 natural log of x squared plus 1. And so then we add the x and what we just got here, the 1/2 x squared plus 1 plus c, and we have our complete answer, indefinite answer. Okay, so let's look at changing variables and how that's done. This is where you have to get a little bit creative, whereas we know that the u has to be the x plus 1, but you notice that doesn't cancel out with the 2x in the top once you substitute the values back in for u. And I'll show you what I mean here. So u would be x plus 1, and so du dx would just be 1, and so du is equal to dx. And when we plug that, du, and when we plug that back in, you'd have dx over u squared times du. And we still have that pesky little x, and that's where you have to get creative with this back here and solve for x. So x would be u minus 1. So pick up from here, see what you can do substituting the u minus 1 in there, and see if you can't figure out how to integrate this. Now let's see how you did getting creative, plugging that u minus 1 back in there for x. Now everything's in terms of u, which is amazing, but then it's just logistically, how do we get this so that we can integrate it? Well, what I did is I took that 2 out front, so I took that out front, that's where that came from, and then I divided up my fraction, basically what I have, right? So u minus 1 over u squared can be written as 2 parts. It could be u over u squared minus 1 over u squared, and u over u squared simplifies to 1 over u. Then you can integrate them separately, so the integral of 1 over u is natural log of u, and the integral of negative 1 over u squared is positive 1 over u, because you add 1 to the exponent, that would make it negative 1, and then divide by negative 1, that's where the positive comes from. Okay, now you still have this 2 outside. Essentially we're done, but since we still have that 2 on the outside, we can then choose to multiply it back in, and this is your final simplified answer. Again, you can make this x squared plus 1 squared to get rid of that. It's just entirely up to you. If it's multiple choice, you need to be familiar with both ways. That is where we will stop with this video. In the next video, we will do some more examples, but now with some trig functions and how to use these same rules with trigonometric functions.